3 address code. So what is 3 address code? This is a very important topic. 3 address code. In 3 address code, each statement generally contains 3 addresses, 2 for operands and 1 for the result. That is why it is termed as a 3 address code. It is a popular form of intermediate code used in optimizing compilers. It is a sequence of statements having a general form. A equal to B operation C. For example, I can say that A, suppose it's T1, B is, say, A, operation is a multiplication, and suppose this is T2, C is T2. So this way we have to represent the 3 address code, where OP is any operator like plus, minus, multiplication, etc. and ABC can be variables, constants or temporary variables generated by the compiler. We can say that the 3 address code is linearized representation of a syntax tree. So we can also say that 3 address code is nothing but a linearized. So it is represented in linear form of a syntax tree. In 3 address code, x into 5 minus y, how can you represent this? X into 5 minus y. So in T1, I will store x into 5 and in T2, I will store T1 minus y. This is my T1 minus this y. In general, when generating 3 address statements, the compiler has to create new temporary variables as needed. The advantage of using temporary names for intermediate results is that the 3 address code can be easily rearranged. We use a function newTemp that returns a new temporary each time it is called. Temporary names must be generated to compute intermediate operation. Addresses are implemented as pointers to their symbol table entries. So let's see an example of 3 address code. For example, if I have been asked to write the 3 address code for A plus B into C plus minus B into A minus B. How do I write the 3 address code? First I will write T1. In this T1 I will write this part, B into C. Then I will write T2, A plus, this is A plus T1, we have stored this, so A plus T1. Next in T3 I will write minus B. Then in T4 I will write minus B into A, that is T3 into A. Then in T5 I will write, so this part is over. T5 what I will write? T4, sorry, in T5 I will write T2 plus T4. T2 is what? T2 is my this part. Then you have a plus. T4 is my this part. And in T6 I will write T5 and this B is there, minus B. So this way I will write the 3 address code. Let's take one more example. Example number 2. D equal to A plus B into C plus A into B into C divided by minus C. So in T1 I will write first A, in T2 I will write C, in T3 I will write B into T2. In T4 I will write T1 plus B into T2 is what? T3, that is B into C. So this part is done. In T5 I will be writing T1 is A, so T1 into T3 is B into C, so into T3. In T6 I will be writing, this is a plus sign, this we have already done in T4 and this we have done in T5, so T4 plus T5. Then in T7 I will write this part, that is minus C, so minus T2. T8 will be this whole thing divided by T7. So this whole thing is present in T6 because T6 was T4 plus T5, so T6 divided by T7. And in D I will write T8. Let's see one more example. Example number 3. A into A plus A into B minus C plus B minus C into D. So first I will write in T1 I will write B. In T2 I will write C. In T3 I will do T1 minus T2, that is B minus C. T1 minus T2. In T4 what I will do? I will store value of A. In T5 I will do this part, that is T4 into T3 because in T3 I have done B minus C. In T6 I will do this part, that is A is your T4 plus this full thing is stored in T5, so T4 plus T5. Then I will write here T7. In T7 I will store this D. Then in T8 I will do, this is T3 is T1 minus T2 B minus C, so I will do T3 into T7. And now there is a plus sign, so this full thing plus this full thing, this full is stored in T8 and this full is stored in T4 plus T5, T6. So I will do T9 is equal to T6 plus T8. This is the way we have to solve for 3 address code.